I was asked to give a quick talk on NISMOD, and as Brian said, this is an integrated assessment framework that is currently being deployed onto DAFNI. So it's currently not ready, so we can't give a live demo, so you won't see any screenshots of the DAFNI platform. So I'll give an overview of what NISMOD is. So NISMOD is basically a framework for sort of predicting and forecasting, analysing future infrastructure developments based on a whole load of scenarios and different sort of parameter sets. And it's been developed as part of the ITRC consortium, which is based in Oxford and run by Jim Hall. And it's led to work including the National Infrastructure Assessment, which I contributed to, and more recently work on the Oxford-Cambridge corridor. So go on to slide 3. There we go. So the platform is a self-developed modelling platform by the consortium. So the design has been self-contained before we talked about migrating onto DAFNI, which is why it's a bit more complicated to migrate over than what hopefully OpenCLIM will be. So the idea is to predict future infrastructure development, taking a whole host of scenarios, so population, demographics, economics, land use, those sort of things, a whole host of scenarios. And then within each model, we can also have different scenarios. So of zero carbon scenarios, sort of move to electric for transport and cars, those sort of things. We can parameterize each sector model, of which there's 6. So energy supply, energy demand, digital communications, that's focused on 5G, transport, water supply as well. So we can start analysing those and predicting those, how they will change in the future, given a whole host of scenarios and future plans. All this is underpinned by a database for which we have various web interfaces as well to help interaction with. For those who want to know more about NISMOD, there is actually a DAFNI NISMOD webinar, I believe, in the next few weeks. I'm not directly involved in that, but there's a link there on the bottom of the slide, which can hopefully be sent around as well. There's a slightly more detailed diagram of the actual how it looks. So you see we've got 4 scenarios, 4 strategies, which includes sort of planned new infrastructure developments, how we might manage demand going forward, maybe shifting to using cars as storage for energy as well as for transport, for electric, and various other spatial and government policy-led strategies. And also at the end of the model, we can look at all the results and look at metrics of how those infrastructures have sort of performed over different scenarios. So that's just that. So looking at how we actually do that from a data perspective, we're talking about modelling infrastructure at building level in some cases. So that's like 60 million buildings in the UK. That's, how do we get energy from energy, water, other services, each of those individual buildings? This quickly creates quite large data sets which we need to handle and think about carefully to make accessible for the modelling. And obviously there's also a lot of security and licensing issues around a lot of this data. So some of it comes from Ordnance Survey, but some of it also comes from private organisations to help inform the decisions and policies that we test. So to handle that, we have a series of databases. So they could be traditional sort of tabular relational databases, or they could be more sort of graph databases better designed for handling the large complex networks such as electricity and road networks. Then there's other sort of databases that can be used as well, sort of object store, which I believe is the way DAFNI currently handles and stores data at the moment. And all these can be linked, and in this case can be linked using an API. So that allows models to pull data from the database using a single URL to pull the data into their models to do the modeling, and then it can also write data back into the databases using a second URL to manage that data transfer, and that hides the complexity of the database arrangement. The models don't need any knowledge of how data is stored. We can also use this approach for managing the admin and the sort of logging while models are running, to log progress and errors and a whole host of things while we're running the models. So there's just another simple diagram of how it actually looks. So as I've said, we can use models to use the database for all the modeling, and other models can write and read directly to and from the database. This is also linked to visualization, which I will now attempt to demo. So let's see how this works. Let me find the right web page. There we go. So as part of NISMOD, we have a web page, and this shows, this is what we call the results. So if I go back, that didn't work. Where are we? Can you still see the web page?
Yes.
Yeah, brilliant. So this is sort of the simple introduction entry point. So you can see individual sectors results, or you can see the sort of combined results across a full model run. So if we look at the cross-sector results, that's loaded properly. I would give a live demo of the NISMOD platform actually running on the Newcastle servers, but due to a IT incident here, I can't actually access the servers at the moment. You may know what that is if you've been reading the press lately. So this is, we group all the model runs into themes. So for example, we could look at the model runs that we've used for the National Needs Assessment or the National Infrastructure Commission. And then within each of these themes, we can have packages. So they might be for a specific sector, it could be for a specific sort of set of strategies. And then within each of those, there's then a set of model runs as well. So these individual times the model's been run. So in this case, you can plot the results. So this fetches all the data from the database, generates the plots on the fly, so you can interact with the data, and we can turn layers off and stuff like that, refresh the graph so we can see the results. One of the key themes around this work, and for the National Infrastructure Commission in particular, was to ensure that we can actually go back and see how each of these results was generated. So if I click on a model run, in this case, we can get all the metadata for that model run. So we can see when it was created. There's an option to write notes when the model run is created about why this model has been created as details. We can see the 3 scenarios, so population, economic growth, fuel price scenarios. So they're the main drivers. And then for each sort of model, so transport, wastewater, energy, we can see information about the actual strategy for that in particular model that was used. If you want to see more detail, we can actually see the individual parameters per model that was used. It's very basic interface, but it's all we need to see all the individual actual parameters that went into that model run. So in theory, we can go back. This model run was run in 2015, September 2015, but if we want to, we could go back using this interface and the database, and we could rerun this model again and expect to get the exact same results. And this information is obviously quite key for people for having confidence in using the models, especially when they've got to sort of be used for key decisions and informed policy decisions. So that's a very quick overview of what we've done on this model, and hopefully that'll help inform what we might do in OpenCLIM to some degree. Obviously slightly different context, but hopefully it should help us decide and make decisions on how we progress forward. Thank you.